Awesome. How often do you measure every training session?
No, I think for this test, we try to implement it because, as I already said, the Germans did not any testing regularly. So they use the system just for analysis of technique, but not for monitoring. So we try to do it once a week. That was on the Monday. We choose a Monday for the testing because we try to implement it in the regular training process.
Hi, Ingo. Welcome to Evidence Strong Show. It's my pleasure to have you. If you could briefly introduce yourself.
Thanks for having me. My name is Ingo Sandau. I am a researcher for weightlifting at the Institute for Applied Training Science in Germany, Leipzig. And I have working for 12 years with the German weightlifting national team as a researcher. The last 2 years, I changed my position and now I'm the head of the Strength and Power department here at the Institute for Applied Training.
Awesome. So your credentials are vast. You are well known in the research community and especially weightlifting. So I'm excited to talk to you about one specific paper. So the paper's title is Long-Term Monitoring of Training Load, Force Velocity Profile and Performance in Elite Weightlifters, a case series with 2 male Olympic athletes. So why this study?
All right, that's a good question. I think we developed the specific test I wrote about, the force velocity relationship with the snatch pull exercise for weightlifting, and we tried to implement it. And I think as a researcher, it's good to publish some results from things we do, so others can read it and maybe can judge it or can talk about it. So that was the two sides of the medal. Just the main part was developing a test for the German Weightlifting Federation, and the other side, as a researcher, I think it's necessary to publish some results of it.
Awesome. I really appreciate that. So before we go into the test, would you be able to tell me why German national team wanted some kind of test?
I think it's German weightlifting training has a long history, and I think a specific monitoring test was missing. So when you look at other countries, they use the isometric mid-tight pull or something like that, but in Germany we didn't have any kind of test. We just looked for how the specific performance in some exercises are developing across the macrocycle, but we did not measure how they develop. And that was, for me, I think it was a necessary thing to develop a test which probably can measure important parameters to analyze or to investigate how the performance or the physical parameters are changing in relation to training, and in order to control or to analyze how the planned training is realized with the training. And so just for this was I think the first idea, just to look how the training is going on and is it the right direction as the coach was implementing in the planning before the macrocycle starts. So that was the main idea for monitoring. And as I already said, in the German system, no specific monitoring test exists.
Okay, so there is a training plan. The athlete's supposed to go through certain phases, and these phases are designed to elicit some kind of adaptation. But to know whether this adaptation is happening, we have to test somehow. And 1 RM testing would be perfect, but it is taxing for an athlete. It has some other risks related, so maybe not always feasible to do. So we're looking always for some kind of cheat code and a test that can tell us everything that is happening with the athlete in the moment, preferably without maximal testing. So you decided it will be snatch pull. Could you tell us what are the parameters of this test?
I think we choose the snatch pull because the Germans love this exercise, and it's an exercise. It's almost in every training session. We love the pulls, especially the snatch pull, and so we try to develop a test that is very easy to apply in the daily training. So we go to the snatch pull test, and I am not doing any new thing. I implemented some idea from the vertical jump with the force velocity profile and transferred to the snatch pull, and like like the typical parameters you get from this profile as the maximal theoretical velocity, the maximal force, and the power output. And also with the knowledge of I call it the threshold velocity for each athlete. When he's snatching the 1 in a competition, the barbell needs a specific vertical velocity, and I put this specific velocity in the model. So we were able to calculate the theoretical 1 snatch from the snatch pull test, and that's the main 4 parameters you get out of the test.
Awesome. So let's go and please tell us how the test was performed.
And during the training?
Yeah. So did you use force plates or did you use transducers? How did you measure the parameters you wanted to measure during this?
The Germans, together with our institute here in Leipzig, a long time ago, they developed a video analysis system, and that is the gold standard system for the German coaches and all over Germany. So a lot of people have access to this software, and that is the main measurement system to get the information, the kinematics from the barbell. And it's very easy. You just only need just a predefined height that is measured for the test. That it's like a constant, and you need to measure the vertical velocity, and that's the input parameters. And from this input, you can calculate everything you need for the force velocity relationship.
Awesome. How often do you measure every training session?
No, I think for this test, we try to implement it because, as I already said, the Germans did not any testing regularly. So they use the system just for analysis of technique, but not for monitoring. So we try to do it once a week. That was on the Monday. We choose a Monday for the testing because we try to implement it in the regular training process. So on Monday, there are some snatch pulls. Most athletes use the snatch pulls on Monday. So we tried to add the test in the training session where they're doing the pulls, and just making their training session afterwards they were going to the test.
So you had 2 athletes who you were following for 40 weeks. So it is, let's say, 9 months.
Yeah, almost.
Yeah. And they had some competitions they were preparing for. Was it Europeans and the Worlds?
That's correct.
Yes. And every Monday you would test them on snatch pulls.
So we have around 6 to 8 athletes who are performing the test, but at the end, only 2 athletes have data for a good analysis. So just make this single case study with the 2 athletes because I didn't have any good value for the other. So I think it's not fair to analyze it. And to be honest, it's not good to publish these results. So that's the other side of the medal. I just have to look. I wanted to publish this, but I think the quality of the data I have to on a good level. So it's just 2 athletes.
So this is a common choice in research. You either go for bigger number with some missing data, or you go, no, I want good quality data, and then you were left with 2 athletes. So that's still good. That's still a valid point. We have a good data set for 2 athletes, actual athletes that were preparing to Europeans and Worlds. I had some more questions about the test. So when they were doing the pulls, did they have prescribed load they had to use?
We tried, as I mentioned, we tried to combine it with the snatch pull in the training session. And and every week the coach set some load to lift for the snatch and the snatch pull. And we tried to use in the snatch pull 70 and 110% of the load they want to snatch. So that was the goal, and that was around 100% in the snatch pull of this week. So it's nothing more, it's just in the range their typical loads they use in this week. So it is nothing special. And then that was one of the things that the coaches wanted to. They don't want to have an extra test with extra loads, so they want to do it within the regular training. So that's also I think the borders you have to walk in with when you're doing tests, especially with the national team. They're preparing for world championships, and I'm the researcher and can say, oh, let's do it like this and like this, and the crew said, oh no, we are training for the competition. You can do your test, but be aware of something special. Just use regular training. So that's not that easy, I think.
Yeah, that's a common problem, I would say. Is there anything you wanted to to add about the test?
I think it's a good test because the results I get just for also for other athletes are pretty good. So I would be interested if some other coaches, researchers are using this test and report their opinion or how they are measuring on is it also working in other settings like the German system, because everything it's always the same. If you develop a test and also you validate the test with your athletes you are doing with, but maybe it's not the same as other athletes from other countries with other training system are using the test also. Maybe other coaches not relying on Snatch pool. I don't know if the Snatch pool in other contexts are working so good to predict the Snatch 1am, for example. I don't know.
So I hope someone from the audience will contact you and say, yeah, we use it. This is what we found. But you're right. The German system has this advantage that Snatch pools are used widely in programming. So everyone is very, very familiar with this movement. Therefore, you found it correlates well with the maximal performance. So I think we know more or less how the test looked like, but now could you explain what you were measuring and what you were looking for?
We studied, the first thing I have to mention, it was, I think the first time the force velocity relationship was investigated in weightlifting in a monitoring purpose. So the first thing was, we wanted to look at how the force velocity profile is changing from week to week, and is it possible to measure some changes in order to have an idea, is this a significant change or is it just you just measuring any kind of noise, I think. So that was the first thing, and I think it worked very well. So the test is, I think, is pretty good for the reliability. So I was able to measure very small changes. So it's from the conclusion was that you can measure or you can apply the test to measure weekly changes of the force velocity profile in case of the maximum velocity, maximum force, and the power output. And it's changing over the macrocycle. And the changes are in line with the idea of this, the idea of the macrocycle, that at the beginning the velocity component is more or stronger, and with the ongoing macrocycle the maximal force is increasing. So it's just like a wave. So you start with high velocity and you end up with high force. And I think that's the main idea for the German system, because you have some tests for the back squat and the front squat around 2 to 4 weeks before the competition. So the maximal strength is at the end of the cycle, and also the maximal force we measure with the force velocity relationship. So it's very close. And also that was interesting. We are looking for the correlation from the Pmax, the maximal power output, from week to week with the 1am and the Snatch. And we found that it's a very high correlation with not with the maximal velocity or maximal force. It's the maximal power output that is highly correlated with the 1am Snatch. So we found it's a nice parameter to analyze the training or to monitor and to change the training. So that was one thing. We just want to look how the test is during a macrocycle, and the other was are the changes from the maximum velocity and power, are they related to training loads and exercises they use during the training? And there are not that high correlation, but the idea from the training is also translated to the test. So if you are doing some heavy pulls, you see that the maximal force is going up, and if you're going or using some lighter loads, the maximal velocity is going up. So it's a close connection from the training loads to the physical ability, and in the physical ability to that you measure with the force velocity profile. So I think it's not the end, but a good start to not only to analyze the training, but only to change or to manipulate the training for future. I think the most analyses are, okay, we did a macrocycle for weeks, and we look back and say some retrospective analysis to say, okay, we were doing this test, and that was the result. But I'm interested in, okay, what is the actual performance of the lifter and what we have to do the next week to increase some specific parts to increase the overall performance. And that, I think, it's the main goal I'm looking for. But the test right now is not capable to do this.
So let's sum up a little bit. So you tried, the first goal was to see whether tests actually can detect the changes in training. And that was a success. So the test was closely, the parameters you found in the test were closely following what the coaches were trying to do in the programming. Is that right? And now in terms of finding what variables that you can measure during the test are correlated with the performance, you found that maximal power was correlated the most. Is that right?
That's correct. At the end, the maximal power is the product from velocity and force. So it all depends together. But at the end, it's one specific parameter that was a Pmax that was highly relevant for monitoring and also for increasing the performance, or to rate how the performance is increasing over the macro cycle.
All right. So now we know what you have found. So how would you recommend coaches apply it into training?
Oh, that's not so easy to recommend something, because I just have a small view from two athletes. I think one of the main things we found was that, interestingly, we have one athlete who is changing the body weight category down. He has to lose around, I think, 7 to 8 kilograms. He's going from 69, it was that time, 69 to 62 or 61. I don't know exactly, but he lost around 8 kilograms. And we also, in this athlete, we are trying to monitor the performance and the maximal force and the maximal velocity, and we found that every measure performance is going down. The Pmax, the maximal velocity, the maximal force, and it doesn't matter what the athlete was training. He trained the squat, the pulls, the snatch, everything like a regular, more or less regular training. But at the end, from physical performance, nothing happened. So the fact that he had to lose a lot of body weight was the killer for the performance. And you're trying to, and if the coach is trying to have and try to implement a training that he can also lift or have a high performance with losing body weight, that was not the fact. At the end, the performance drops, and that's, I think some other paper already discussed it, that the body weight is on the regulation of the body weight, and especially for athletes who need to lose some weight for the competition, is extremely important. And you have to figure out how is the right way with the athlete to manage the process of losing body weight and still not to lose so much performance. So that was one interesting thing. That was not the main focus of the study, but one thing we are looking afterwards. We are looking at, and we came to some conclusions to maybe better or to optimize the process of losing body weight. And I think with the new system for Olympics, with the Olympics and non-Olympics body weight category, some changes or some switching in categories are very interesting for some athletes. And I think if you go down to a body weight category, you have to lose some body weight. It's very hard to manage the training process, because the fact that you're losing body weight is the overall fact that hinders your performance. And I think you need to be very clever to have a good idea how to lose the body weight and not to lose so much performance.
Okay, and what can we learn from the athlete who was not using the weight and his performance went up, I assume?
Yeah, I don't know if I can, as I mentioned, I'm not sure if I can transfer the results from one athlete we measured to maybe population of weightlifters who are lifting all over the world. But we found that it was a very simple result, but we found that the programming of the training, and especially at which phase which performance or which capability is increased, was very good was highly correlated with the performance test. So we found that the training process with the other athlete was very well designed, because like the opinion we had that the maximal force is increasing and to the end of the macro cycle, and also the maximal power output is maximal at the end of the macro cycle before the competition. That athlete performed very well with this, and we could measure that. So we a little bit satisfied that the idea of training with a German system wasn't that bad, because we also measured with a test and we found the same results with the idea of the coach. So that was, I think, for the German system, especially for the coach with a specific athlete, was a very good finding. So I was able to confirm his idea of training. At the end, this athlete, that's 2 macro cycles for the European Championships and the World Championships, ended up with very good results.
That's
But
awesome.
again, it's very hard to transfer. That is the drawback from a single case study. It's very hard to give some recommendations from one athlete to coaches.
I understand. I was teasing you a little bit. But, you know, we know this much from these 2 athletes. We need more data. So if anyone has the capability of test the athlete, they should contact you and send you the data so you can have more data to work with.
And would be great.
Awesome. So 2 short questions to finish. What is your favorite color?
Yes, blue. I said blue.
Awesome. And where people can find you if they have some data for you, where they can catch you online?
The typical ways on ResearchGate or LinkedIn, or just type my name into Google, and I think there's one way to contact me.
Awesome. Thank you, Ingo, so much. It was a pleasure.
Yep.